In a monolithic app, all software components are in a single process and there is no distribution of any kind. Let's take an example of an e-commerce app for selling goods and products like Amazon. It authorizes customers, takes orders, checks product inventory, authorizes payments, and ships products. Traditionally, if you're building this e-commerce app monolith way, you'll have all these components as backend services in a single process, a user interface for customers, and maybe a database such as RDBMS. As you can imagine, it is easier to design, simple to deploy, and can give you high performance because there are no network hubs. But a monolithic application can quickly become too large and complex to understand. Its ever-increasing size can slow down the startup time. Sometimes for a simple change, you might have to deploy the entire application. And if a specific service requires more resources, the entire application needs to be scaled up. Furthermore, let's say alongside your e-commerce app, you also have an internal customer service application for customer support, which is also a monolith. Now, if a new requirement comes up which requires e-commerce app to share data with customer service app in a monolith, it is extremely cumbersome for applications to talk to each other. Service-oriented architecture or SOA made applications talk to each other and sharing data easy. It allowed different platforms to communicate. For example, it enabled Java service to communicate with .NET service. Many considered it the cornerstone of any distributed architecture. SOA architecture achieved this using SOAP protocol, a specification for exchanging structured information, and an abstraction layer, ESB, Enterprise Service Bus. ESB in particular is the backbone of SOA, but quickly became complex, expensive, and difficult to maintain. Small companies especially started avoiding them. Moreover, testing and deployment in SOA compared to monolith became really challenging, and due to lack of tooling, there was no time saving achieved. Microservices are a result of shortcoming of these two architecture paradigms, monolith and SOA. In contrast to monolith, microservices architecture aims to break down an application to isolate key functions called a service to meet a specific and unique business need. At the same time, it was supplemented with the necessary tooling for testing and deployment and freedom from Enterprise Service Bus. The term microservices first appeared in 2011. Martin Fowler and James Lewis published their first microservices article, which became the de facto definition of microservices. Taking the same example of e-commerce application, in a microservices architecture, we build each component as a separate, loosely coupled service, which may collaborate with each other based on the business requirement. For example, we'll have authorization service responsible for authorizing customer, an order service that takes an order and processes it, a catalog service to manage products and check products inventory, and a payment service to manage and authorize payments. Now, each microservice is relatively small and easier for a developer to understand. And since services are smaller, they're easier and faster to test. It enables each service to be deployed independently by a team that is focused on that service, and reduces barrier of adopting new technologies, since the developers are free to choose whatever technologies make sense for the service and not bounded to the choices made at the start of the project. At the same time, all the benefits of testing, troubleshooting, monitoring, and deploying microservices can become complex when there are too many of them and are dependent on each other. Microservices architecture is a popular choice for complex, evolving applications. In fact, the microservices approach is all about handling complex systems. But in order to do so, the approach introduces its own set of complexities and implementation challenges, and might not be the silver bullet for all the problems. Depending upon the use case, you might consider going monolith first. We will cover some of the challenges, common patterns, and characteristics of microservices for its proper application in our future video.